This is information physics according to Jim, and um, I want to introduce you to a world where, as the evidence suggests, the universe is quantum mechanical. It has a logical nature rather than a physical nature. And it doesn't happen just on the very small level, it happens on every scale. I mean, radio waves are huge, and they, obviously are controlled by quantum systems, and there's a different quantum logical system at every distinct frequency. But let me introduce this to you. I'll share my screen and show you some things here. But the really strange thing about quantum physics is that it's not really strange. It's just very different from what we expected. And we expected there's to be a duality, a dichotomy in the world where we had the physical and the mental and the spiritual. Well, the information nature implied by the quantum unifies the mental, physical, and spiritual, in that the physical things, the repeated memes, are part of a universe that's mimetic in nature. It's just repeating signals that carry information. Um, and when we think, there's, this is a quantum system. All systems can be considered to be quantum in nature. And this is sort of what I'm trying to communicate in this video I made yesterday. I've been blessed with understandings based on what we know about the universe that are radical in that they are so different from the standard model where we invent things like free particles, which are impossible in quantum. We haven't come fully to terms with the idea that the universe has a quantum nature, which is a digital nature with complementary logic that is obeyed universally across any distance forever. A particle is made of energy, and the energy is made of bits of information, each one entangled somewhere in the universe, instantaneously becoming logical. And we have to ask ourselves why the universe is logical. And then we have to say, well, how can it be any other way? The logic is eternal and perfect. It's universal. It's not constrained by Gödel incompleteness. And it doesn't support the law of the excluded middle. Proposition can be both true and false in different contexts. Quantum logic is correct logic. It's complete logic. And magically, the universe refuses to violate it, ever. The no hidden variables theorem shows that if there was any other influence besides the complete quantum mechanical description of the system, if there was any tiny influence, gravity or anything else, we would get totally different answers. The logic must be perfect, always. And when we do a quantum computation, it's like we listen for the answer, like tuning into a radio station. And somewhere out there is a solution, and we enable it by listening for it. Of course, it has to be a perfect definition of the answer or the question. So I think we have to accept the fact that the universe is a quantum mechanical system having perfect logic. And so there's nothing else to know. That's the theory of everything. The only thing that exists in this world is the logical connections, the complementary logic that is associated with every bit of energy and matter in the universe. Nothing else exists. There can't be anything else. So we know how electromagnetism effect comes out of the aggregate behavior of quantum systems, exchanging photons by delayed choice, least action, and first opportunity. First logical thing that can happen does happen. There's no other effect except the logic. And I think that's the mistake that modern physics faces, that it treats our experience as what's really real as opposed to the underlying quantum reality. Free electron is a fantasy. Okay, all we have is the bits propagating by events that happen when the potential would occupy the same state as a different potential, the same momentum state. By bouncing off one another, they have different momentum relativity. It's because they're logically independent. What's manifest is a physical independence. And equal and opposite action is the only thing happening in this world. I think it is somewhat unfortunate that quantum theory was developed decades before Shannon's information theory, because quantum mechanics has an information nature, not physical in the sense that it has logical constraints, not physical constraints in the ordinary sense. And Shannon's theory was a theory of communication. It was about how we understand the information, and the millions of bits that might be part of a photon all have diverse backgrounds and logical constraints, and this particle is or this photon is a collection of bits that can be considered random. Their background, logical connections from the early universe. But some of the bits can be significant. Electromagnetism is ultimately wrong, because you can have butterfly effect. You can have we have information synthesis, and by delayed choice, least action, first opportunity, the quantum effect can become macroscopic of logic that exists on every frequency independently, semi-independently. Shannon's theory of communication was about receiving messages and deciphering the information they contain, and encoding. It spawned the computer and communications explosion. But in Shannon's theory, the bits of information are conditional probabilities. And a quantum bit is similar. It's a conditional probability. The thing is, we have to consider to completely and correctly consider a system. We need to consider each of the possibilities independently, because we can't generalize completely what will happen by delayed choice. We go back before the apparent information bang at the beginning of the universe. We can think of there being a Platonic, all possible logical systems. That's the dual of a universe that can only do what is possible. And it seems nearly impossible that a distance, a logical distance between two things could become a time delay. And all possible logical systems, nothing happens without a delay element, without some time element, so that it can do universal computing. So eventually, quantum doesn't enforce conservation of energy, but except on average, it will tend to. Now, in the inflationary universe, we do have information being generated, and it's that every new event creates information, and we don't have conservation of energy globally. Now, I'm sitting here in this room, and half of the quantum information is going off into space, being lost forever. So, as far as I'm concerned, there's a conservation of energy and therefore information in this room. Um, but delay is introduced in quantum systems by other dimensions, the dimensions inside atoms, muons, the logic or energy, the bits of quantum qubits of quantum information enter the atom and are delayed, and local time is exhibited, as well as universal computing. The problems with the standard quantum theory is that it's based on classical assumptions of continuum, and no continuum is evidenced by the quantum. In fact, quantum logic contradicts any continuum of any specific number of dimensions. You can always construct a quantum logical system with more dimensions. Although, to have matter, we need to loop these logic such that it exhibits delay in one place. A more reasonable formulation of quantum is that energy is composed of a vector or of qubits or quantum or conditional possibilities, and that they and rather than presuming uncertainty, it can be shown that uncertainty is due to missing information. So when we say something is uncertain, we're being inaccurate. It can be undetermined, and it's impossible really to have complete information about a quantum system that's not isolated. But if we base our postulates on what we know, okay, which is quantum logical action manifest as with two physical constants, the speed of light and Planck's constant. All other constants are emergent from systems, quantum logical systems that are have only two constants that constrain them. And we have distance equals speed of light times time, and we have energy equals frequency times Planck's constant. And we don't need to add any other form of energy. We have all this huge amount of energy from the Big Bang that gives us space-time that has an energy. And as Wheeler said, it's only marginally less energy dense than matter. But the vacuum looks like nothing because the information is near maximum entropy. We get no information from it, but it doesn't mean that the energy isn't there and prolific. And understanding the nature of the vacuum makes things like dark matter and dark energy very understandable. Light goes slower in the vicinity of masses. And that includes center of galaxies, whatever. And if we know that if the energy has a lower light speed, it exhibits a rest frame. And if it exhibits a rest frame, it'll exhibit gravity. More on that later. If the universe started with chaos, we would have random quantum logical machinery being generated. And there's a countable infinity of these logical machines, starting with the simplest to the more complex. So we can pretty much presume that every quantum mechanical system up to some level of complexity has been manifest. And those that conserve information remain, those that lose information are gone. In the evolutionary cosmos. Each quantum logical action or transform in matrix mechanics can be thought about a little twist in nothingness that can be right-handed or left-handed, approaching or receding. And this gets manifest as to us in a physical space. And this is how this emerges is in a discrete manner where you have one twist, okay, that maybe up and to the right, and you have another one down to the left. Okay, you have frontwards, backwards in 3 dimensions. Now, there's nothing in the quantum that when it's synthesizing space-time, it has to synthesize directions that are parallel to existing directories or perpendicular. The logic determines how many dimensions it needs in order to exist. And if we think of this as a computation, it's how many variables are in the computation. If we have one variable, that's 1 dimension, 2 variables, 2 dimensions, 3 variables, 3 dimensions, 4 variables, 4 dimensions. And clearly we're going to have systems of many variables that can be created randomly in a chaotic quantum logical environment. But we can see how, the one twist manifests two dimensions, interaction of electrons and such, two-dimensional. Now, if a bit is constrained to be orthogonal to the two dimensions that are here, we get the third dimension, and that's what we see in space-time. And most, we can represent any graph in 3 dimensions, but if we have another constraint that we need to be orthogonal to these 3 dimensions, we have a 4th dimension, and this is what happens in atoms. We have a complex system, okay? It has a lot of bits according to its mass, thousands of bits of information. And the electron potentials, which are right-handed, enter the atom and are twisted into left-handed dimensions. And so what you had on the outside was an electron potential, and what you have on the inside is a positron potential. So the basic quantum creation operator creates an electron-positron pair, and these two differences are entanglements between the two that remain have eternal logic to them. And we have a one-dimensional neutrino, which sort of doesn't exist. It's half of the electron positron. We're only considering one of the differences in the electron positron pair. And then we have the next most complex structure, which has an internal dimension, which is the anti-muon. And the muon doesn't exist. No particles exist independently in the quantum. They're always connected with other particles in a whole system that determines how they behave. The anti-muon is called a light proton because it acts like a proton in that it has internal dimension where a signal comes in or a potential comes in, and the electron potential comes in and is sort of trapped in another dimension. It travels in another dimension. It's actually bigger on the inside than it is on the outside, like they're coming to realize about black holes. And this is just like a black hole. It comes in and it's stuck in there. And what happens is the potentials of the electron get twisted into the potentials of a positron. So we have the positron potentials matching the electron potentials, and we have a delay element so that when the signal comes in, it gets delayed in another direction in one place because it doesn't line up with our 3 dimensions. And then we have the hydrogen atom, which has several internal dimensions, which is the first really stable atom. And we have essentially the signal coming in gets delayed internally. We can consider the internal side of the atom to be antimatter and the outside to be matter, and they're equal ultimately. We'll take one final look at the universe here, where we have the Big Bang in the center. Okay, and we have space created in the blue, which is essentially photons. They're electron interactions, are photons. And so all of our electron interactions are out here, and there is no missing antimatter because the antimatter is all in the protons and atoms, other atoms or masses that always must equal the electron potentials, because there's no way to create one without the other, and it can never be lost. So let me know what your questions are, and I'll try to do a piece to answer those questions. Thank you for listening.